Third grade. Okay, this is something so cool that I wanted to show you. In the last video, I was saying how even though most of the shapes that we see are not triangles, we can divide a polygon, just kind of drawing lines through a polygon, and we can divide it into triangles, okay? And once you start seeing the triangles inside the polygons, it's kind of amazing and kind of cool. Okay, so just take a look. I do a couple polygons. Actually, Jack drew them for me, but have a couple polygons here on my grid paper. And using grid paper makes it easier because you can exactly tell. Okay, so obviously this is a rectangle, okay, because it has two sets of parallel lines. It has four right angles in each corner. If I take and I draw one line from one corner and I draw, let's say the rule is draw a line from one corner, they call vertice, one vertice to all the others. Well, if I drew a line to this one, that would just be that side. If I drew a line to this one, it would just be that side. So really the only new line would be right here. And that would divide my rectangle into two triangles. Now let's describe the triangles. The triangles are two, what kind? Well, let's see, there's perfect square, the perfect 90-degree angle. So this would be a right triangle. It also, we can tell by the squares that each side is a different length. So it's a right scalene triangle, okay? The same would be true of this. This is actually a line of symmetry, right? Which we haven't gotten to, but you know that. Okay. Now let's take a look at this polygon. 1, 2, 3, 4, 5 sides. I'm going to go from one corner, one vertice, and I'm going to draw a line to every other vertice. Well, that's just that side, right? Here we go. Boom to this corner. Boom down here to this corner. And then this would just be that side, correct? Okay, so if I start at one corner and I draw lines to every other corner, I'm going to come up with 3 triangles. Now take a look at these. Look at this. Boom, boom, boom. Is that a right triangle? It is. Look. Right? You can see that. It's not exactly on this grid as a right triangle, but we could tell that that's half of that and that's half of that. So therefore, that is a whole square right there. You see that? So that's a right triangle. What about this one? Are any of those right? No. Are any of them obtuse? So this would be an acute triangle, right? This would be an acute triangle. This one right here, acute triangle. It looks like it might be an isosceles, like that this side and this side are equal. I'd have to get my ruler out to measure exactly, which I could. Okay, and let's take a look at this one. I know what this is bigger than a 90-degree angle, so this is an obtuse triangle. Okay, so then let's take a look at this hexagon. Hexagons have 6 sides. I picked this corner and I drew to every other corner. That just made that side. Boom, triangle, boom, triangle, boom, triangle. That would make that side. Okay, so a hexagon, I have 4 triangles. Can you see which ones are obtuse? This one is obtuse, obtuse. This one's obtuse. How about this one? That would be, looks like it could be a right triangle, doesn't it? Boom, doesn't it? Right triangle. How about this one? I think it's a right triangle. Now, what is really cool, we could get if we had a protractor, which I don't have here on my Jamboard, but we would notice, and this is what I was trying to tell you, is that all the angles in here equal 180. So if this angle right here is 90, then these two have to equal how much? 90 together. So they're probably 45 degrees and 45 degrees if it was divided equally, right? Because all 3 angles in the triangle need to add up to 90. So 90 degrees, we know right there, because a right triangle is 90 degrees. This one is most likely 45 degrees. If I measured it, it would be 45 degrees, and this would be 45 degrees. And that's true of most right triangles, right? So this one we know would be greater than 90 degrees. So these would have to be less than 45 degrees. That makes sense? Puzzle that one out. It's not 3rd grade math, but I think it's pretty cool. And once you start noticing, you're going to notice patterns. You're going to notice, oh my goodness, is there a relationship between how many triangles I can get and how many sides I started off with? There is. Look, I started off with 4 sides, came up with 2 triangles. Start off with 5 sides, I got 3 triangles. 6 sides, 4 triangles. So what's the relationship? However many sides I have, subtract 2, and I have the number of triangles that I can make inside. Shapes are amazing. So if you can, get your own grid paper, draw a few shapes and see what you come up with. I think geometry is so fun. I hope you do too. Have a great day.